Good day, grade 10s. In this lesson, we're going to be looking at conversions of units. So what we need to know is that all our units need to be in SI units. So distance and displacement have to be in meters. Our time in seconds, so that our speed and velocity is always in meters per second. And I'd like to introduce you, if you haven't met him already, King Henry, who died while drinking chocolate milk. It's a silly phrase, but it helps us remember how to convert things. So King stands for kilo. Henry stands for hectare. Died stands for deca. While is a placeholder. Drinking is a deci. Chocolate is centi. And milk is milli. Now, it might seem silly, but I have matrics who still use this because it gets a bit confusing after a while, especially when you get cube things and volumes and all sorts of weird things. So let me explain how this works. First of all, the placeholder. This placeholder stands for any unit you have. So it could be meters, it could be liters, it's bytes, okay, seconds, anything. That is your unit. Your unit holder, okay, your placeholder. Now let's say, for example, I want to go okay, let me give you an example. If I tell you you've got 10 millimeters, you guys should already know that 10 millimeters is 1 centimeter. But let me show you how this works on here. So if I put a 1 here and a there, do we see we've got 1 centimeter is 10 millimeters. 1 centimeter is 10 millimeters. Okay, let's say I have 1 meter. How many centimeters is that? Well, we've got another placeholder there, that's a 0, and that's a 0. So therefore, we've got 1 meter is equal to 100 centimeters. So you can see that every one of these basically counts for a 10. A times by 10 or a divide by 10, depending on which way we go. So, if say I have 2 kilometers, 2 kilometers would be under the kilo, and then I'd fill in the 0 for the hectare, the 0 for the deca, and the 0 for the meters. So therefore we can see that 2 kilometers equals 2,000 meters. Now let's go the other way. Let's say, for example, I have 50 meters. 50. Now I want it in kilometers. So I put a 0 at the unit that I need, and I put a comma after it because it's obviously less than it. So then it goes like this. So therefore we got 50 meters is going to be 0,05 kilometers. But what am I actually doing? What I'm doing is, as I'm going from the bigger number to the small number, I am timesing. So as I go from this way to this way, from King Henry down to chocolate milk, I am timesing by however many gaps I need, and it's times 10 by every many gaps. Okay, and if I'm going from the smaller numbers, say for example centimeters to meters, I'm dividing by 10 for every one of the gaps. Right, so let's do an example and I'll show you how to use this. So Sarah walks 2 kilometers away from her home in 30 minutes. She then turns around and walks back home along the same path, also in 30 minutes. What they want to know, what is her average speed and what is her average velocity? So Sarah walks 2 kilometers away from her home in 30 minutes. She then turns around and walks back along the same path, and we want to know what is the information given. So they told us that she walks 2 kilometers away and then walks back along the same path, which means she's traveling 2 kilometers away and another 2 kilometers back. So 2 kilometers and 2 kilometers is 4 kilometers. That's pretty easy. Let's look at the time. She travels 30 minutes away and 30 minutes back. So the total time therefore is 60 minutes. But do you see that this is in the wrong unit? These are in the wrong units. They are not SI units. So we need to convert them. So first of all, you can see the answers at the bottom. But let me show you how we got them. So first of all, you can see that we've got 4 kilometers, but let's just do King Henry died while drinking chocolate milk. The Y in this case is our unit, which is our meters. So we're going from 4 kilometers to 4,000 meters. There it is. See how easy that is. Minutes, you actually can't use King Henry died because of the fact that we know that 60 minutes is not it's because it's not under the decimal system. But let's just carry on with this. 60 minutes, 1 minute equals 60 seconds, right? So therefore, we can say 60 minutes times by 60 for every one of the seconds, which gives us 3,600 seconds. So now we've got our SI units. Now let's look at what else we can see. Let's look at the distance and the displacement. So now Sarah traveled 2 kilometers and 2 kilometers along the same path, which is a total distance of 4 kilometers, which we've now converted into 4,000 meters. So her total distance is 4,000 meters. But what is her displacement? Do you see that she traveled 2 kilometers, if we draw it with a vector diagram, this way, or 2,000 meters, and then she traveled back exactly the same path to get back home at 2 kilometers. So there is no difference from where she started to where she ended, which means her displacement is 0. Her displacement is 0. Right, now let's look at what we can work out. Let's work at our average speed. We know that the average speed is total distance over total time. We've calculated a total distance to be 4,000 meters and her total time is 3,600 seconds. So speed equals 4,000 divided by 3,600, which is 1.11 meters per second. Right, so that is her average speed. Now let's look at velocity. Velocity is total displacement over total time. Total displacement over total time. So displacement here is 0. So what are we doing? We're really going 0 divided by 3,600, which is going to give us a velocity of 0 meters per second. Right, now there's one more thing I want to do, and that is convert meters per second to kilometers per hour and vice versa. So let's first look at meters per second. If we want to convert meters over seconds, that's meters per second, to kilometers per hour. Now there's a little trick, but I want to show you the origin of the trick before I tell you what the trick is. We're going from per meters to kilometers. So do you agree that there are 1,000 meters in 1 kilometer? So we need to divide. So we're going to divide our meters by 1,000. And then to get to hours, we have to go from seconds to minutes, and then from minutes to hours, right? So we divide here by 60, and we divide there again by 60. So in the end, we're also dividing this by 3,600. So that is the same as dividing by 1,000 and timesing by 3,600, because we're tipping and timesing for the bottom one, which works out to be timesing by 3.6. So that's a sneaky little trick. To go from meters per second to kilometers per hour, we can times by 3.6. Okay, but I'd like you to be able to understand how we get that. Now let's look at changing from kilometers per hour into meters per second. So we're going kilometers per hour into meters per second. Now again, what do we need to do? To get to kilometers to meters, we need to times by 1,000. And again, to get from hours to seconds, this time, what do we need to do? We need to times again. We need to times by 3,600, which is the same as timesing by 1,000 and dividing by 3,600. So the trick here would be to divide by 3.6. So that is how you convert kilometers per hour to meters per second. But again, I'd like you to be able to know why we are doing it, what the procedure is. Right, grade 10, so that is all with regards to units and conversion of units. I hope you've understood that you always need to get into SI units and you know and learn how to use King Henry if you don't already. Thanks grade 10s, have a great day.